Hi, this is Philip from the Center for Quantum Nanoscience here in Seoul, and I'd like to talk today about this image, which shows the smallest MRI, the smallest magnetic resonance image ever taken. It shows the MRI of only one single atom. And today I want to explain to you how we made this happen. So normally in a hospital, when you take an MRI, it looks more like this. And this shows typically the density of water and fat molecules in the human body. What you see there is actually the density of nuclear spins. A nuclear spin is a tiny magnet that is sitting in the nucleus, in the center of an atom. And by applying a magnetic field and shining in radio waves, we can actually detect the density in our body. But usually for these images you need billions and billions of molecules in order to see something. So what we wanted to do is to make these images for only one spin, an electron spin that's similar to a nuclear spin, and only on one of them. And for that we actually used a special microscope, the so-called scanning tunneling microscope. If you follow our channel, you have probably heard about that already. So it is in the end a very, very sharp metal tip that, similar like reading Braille, you scan across a surface, and whenever you have something on the surface, your tip can feel that. For example, these ball-like structures which should represent atoms. And this is how a typical of these images looks like, and what you have in the center is a titanium atom that we deposited there in order to investigate it. So we can actually already see these atoms. So with our MRI, our single atom MRI, we wanted now to study the magnetic properties of these atoms, because titanium is actually a very small magnet itself, then a spin. And in order to do that, we actually made our tip also magnetic. So we picked up one of these atoms from the surface, and now what we could do is scan still our tip across the surface and feel how the two atoms interact, or the two magnets interact, one on the tip and one on the surface. And actually what we found is that they actually behave similar like classical magnets. If you have two magnets and move them with respect to each other, at certain points they will attract each other and repel each other, and meaning that they have a positive or negative magnetic interaction energy. And by now imaging our tip magnet across the magnet on the surface, we could actually plot their magnetic interaction energy. And this looks like this. So on the left you have the titanium atom, and on the right you have the MRI image, and the bright areas now show regions where the magnetic interaction has the same energy of the atom. And we can not only plot that for one energy, but actually for multiple energies. And by plotting it for multiple energies, we can really visualize the energy of the magnetic field around one of these atoms with very high precision. And in the future, we want to use this single atom MRI actually to study more complex systems, for example magnetism in molecules or in complex magnetic materials. We also want to use it to study and control quantum systems, systems that behave vastly different than classical systems, and that be a great potential for future applications, for example for quantum sensing or quantum computation. So that's it. Thanks for watching. If you want to learn more, please follow the link in the description and subscribe. See you next time.